When we want to show that two functions are inverses of each other, we want to show that when we plug them into each other, we get x. So the first step is I'm going to show that f of g of x is equal to x. F of g of x would be f of 5x minus 2. That means I want to go to the function f and change all of the x's to the quantity 5x minus 2. When I look at f of x, I see x plus 2 divided by 5. So that would be what plus 2 divided by 5? So if we insert g of x, we get 5x minus 2 plus 2 divided by 5. If we simplify each step at a time, the negative 2 plus 2 would be the first to undo the operation. That gives us the next step, 5x divided by 5. Here the 5's cancel, and that leaves us with x. The second step is to show that g of f of x is equal to x. So that would be g of x plus 2 divided by 5. So this means I want to go to the function g and change all of the x's to x plus 2 over 5. So this would, if I look at the function g, I see 5 times x minus 2, so that would be 5 times x plus 2 over 5, and then minus 2. The first operation that would undo would be the multiply by 5 and divide by 5. So the next step, we have x plus 2 and then minus 2. Here the plus 2 minus 2 cancels, leaving us with x. So since f of g of x equals x and g of f of x equals x, we can say that these functions are inverses of each other. Next, let's find the inverse function of f. So I have f of x is equal to the cubed root of x plus 3 over 5. First I'm going to rewrite this so that it's a y equals equation. So f of x takes the place of the variable y. The next step is I want to switch the variables in the equation. So everything that was an x becomes a y and vice versa. So I rewrite it as x equals the cubed root of y plus 3 minus 5. Now we want to solve this equation for y. First we need to isolate the cubed root. So I need to add 5 to both sides. This gives me the expression x plus 5 is equal to the cubed root of y plus 3. To undo a cubed root, we need to raise both sides to the third power. So I have the quantity x plus 5 to the third power is equal to just y plus 3. And that's because the cubed root is undone by the cubed power, and you can bring out the inside quantity. Lastly, we just need to subtract 3 from both sides, so I have the quantity x plus 5 to the third power minus 3 equals y. When you have y alone, you rewrite it using function notation, and it is f inverse of x equals x plus 5 quantity to the third minus 3. This would be the inverse function of f. Now let's try graphing exponential functions. So the first graph, f of x equals 2 to the x plus 3 minus 1, this has the shape of a basic exponential function for 2 to the x, and so it has a horizontal asymptote, and the intercept is always 1 above it, and this is the shape of the curve. Now because we're adding 3 to the power, that's a horizontal movement. So this graph is going to shift left 3 units. It's always opposite of the sign when it's a horizontal movement. Also, this graph will shift down 1. So when we build this graph, we want to move the asymptote first because that's the boundary for the graph. So it always starts at 0. It's going to shift left 3 and down 1. We won't really see the left 3 movement, but we will see that it moves down 1. So the equation of the asymptote is y equals negative 1. The intercept is always 1 above the asymptote, but it is shifting left 3. So this intercept lands at negative 3. So I can say that the x-intercept is negative 3, 0. We have to solve for the y-intercept. The y-intercept is where we let x equals 0 in the function. So f of 0 is 2 to the 0 plus 3 minus 1. This simplifies to 2 to the third power minus 1. Since 2 to the third is 8, this gives me the solution of 7. So the y-intercept is 0, 7. Next I'm going to graph the function. I'm just going to connect those two intercept points that I found. And then the domain of the graph, there aren't any restrictions going left and right, so the domain is all real numbers or negative infinity to infinity. The range starts at the asymptote and then the graph increases up forever. So this is from -1 to infinity. The next graph has the function f of x equals 5 to the x minus 3. So this is taking the basic function 5 to the x power, which has a horizontal asymptote and an intercept at 0, 1, and it's shifting it down 3. So if I move the asymptote first, it lands at y equals -3. The intercept is always 1 above it, and since it's not shifting left or right, it lands at 0, -2, and that is a y-intercept. Now, the x-intercept, to solve for that, we let y be 0. So I'm setting 5 to the x minus 3 equal to 0. We want to isolate 5 to the x, so I add 3 to both sides. So 5 to the x equals 3. Next I'm going to solve for x, and since it's not possible to represent both sides using the same base, we can take the natural log of both sides. When I do that, I use the property that says I can pull down the power as a coefficient of the logarithm. So I have x times natural log of 5 equals natural log of 3. To isolate x, we need to divide both sides by the natural log of 5. So this gives me an irrational number. Natural log of 3 divided by natural log of 5 is approximately 0.683. So I'm just going to estimate the x-intercept. So it crosses at about 0.7, and I can sketch the shape of the curve. And its domain is all real numbers, or negative infinity to infinity, and its range starts at -3, so we use parentheses since that's located at an asymptote, and it goes up forever, so it approaches positive infinity.